Hello everyone, hope you're doing well. My name is Tawfiq Omer, math teacher. In this video I will explain the chapter 1 lesson 3 function and their graphs, part C, domain and range of a radical function. Domain and the range of the radicals function. We classify this kind of function in two types. The first one, odd radical, which it is degree is odd, and even radical, which it is degree is even. Odd degree, we will classify them in two types. The first one is this kind, which the degree of under root is odd and the degree of the root is odd, like cube the root of x and fifth root of x minus 1. X to the power 1 over 3 is the same with the first one, and x minus 1 to the power 1 over 5 is the same as in the second one. These kind of roots, their domain and their range are real numbers, as you can see in these two graphs. The domain is real number and the range is real number. The second type is when the degree of under root is even, as the cube root of x square and the fifth root of x square minus 1 and x to the power 4 over 3 and x minus 1 to the power 2 over 3. This kind, their domain is a real number, remaining the range of this kind of radical function. Take x square equal to 0, then it is 0. Because it is 0, when we replace a 0 in place of x square, its result is 0. Then this one is starting from the 0 to the positive infinity. The second one, when we make x square 0, then it is 0, remain minus 1. Therefore, the range began from the minus 1 to the positive infinity. Here, when we make x minus 1 0, then x is equal 1. Replacing 1 here, it becomes 0. Then the range began from the 0 to the positive infinity. As you can see in this graph, function x is cube root of x square minus 1, which we said here. It becomes the range from the minus 1 to the positive infinity, but the domain is real number. In the second one, x minus 1 to the power 2 over 5, when x minus 1 is 0, then x is 1. When replacing x in 1 in the place of x become 0, then the range began from the 0 to the positive infinity. To find the range, it is better sketch the graph of the function and then find the range. And now we will take the square roots or even radicals. We have two types. The first one, if the sign of the root is positive, and it's classified in two ways. The first one, if the sign of x is positive under the root and sign of x is negative under the root. When the sign of x is positive under the root, then the domain and the range began from the start point to the positive infinity. You can see here fx equals square root of x minus h plus k. then the start point is hk. Because of that, the domain began from h to the positive infinity because the sign of x is positive, and the range began from the k to the positive infinity because the sign of square root is positive. The direction of the functions start from the start point to the positive infinity. Therefore, the domain is start from h to the positive infinity, and from k to the positive infinity is the range of this function, because when the sign of x square root and x is positive, the functions start from the start point to the right and up, like this. But when the sign of x is negative under the square root, then h minus x plus k is the function. Start point is hk. Because the sign of x is negative, then the domain starts from the negative infinity to the h. Negative infinity to the h, because the direction of the function is from the start point to the negative infinity. Therefore, the domain is from negative infinity to the start point, which is h. But because the sign of square root is positive, therefore the range is began from the k to the positive infinity. The second kind is sign of root is negative. When the sign of root is negative, therefore we have two types. Sign of x is positive and sign of x is negative. Fx equal minus square root of x minus h plus k. hk start point. Because the sign of x is positive, therefore the domain start from the h to the positive infinity, because the direction of the function is begun from the start point to the positive infinity. And because the sign of square root is negative, therefore the range began from the negative infinity to the k. The second one, fx equal minus square root of h minus x plus k. Because the sign of x is negative and the sign of square root is positive, therefore domain start from the minus infinity to h, and the range began from minus infinity to k. As you can see, the direction is from the start point to the negative infinity. Therefore, domain is from minus infinity to the h, and range is from minus infinity to the k. In this notations we take, you can say that if the sign of x is negative, then domain start in the negative infinity to the start point. And if the sign of square root is negative, then the range began from the negative infinity for the k. And if the sign of x is positive, then the domain start from the start point to the positive infinity, or from h to the positive infinity. But if the sign of square root is positive, therefore the range is begun from the k to the positive infinity. Example number 1. Find the domain and the range of the function fx equal square root of x plus 2. First of all, we can write this function in the general form fx equal square root of x minus minus 2 plus 0. Comparing with the general form fx equals square root of x minus h plus k, you can see that h is equal to minus 2 and k is equal to 0. Here directly you can say, because here we have positive or plus 2, then h is minus 2. Because we haven't any number adding or subtracting with the square root, therefore k is 0. And then h is minus 2 and k is 0. Because the sign of x is positive and the sign of square root is positive, therefore domains start from the start point to the positive infinity, and the range start from the start point to the positive infinity. That means the domain is from the minus 2 to the positive infinity, and the range is from 0 to the positive infinity. As you can see in the graph of this function, domains start from minus 2 to the positive infinity, and the range from 0 to the positive infinity. Example number 2. Find the domain and the range of the function fx equal minus square root of x minus 2 plus 1. We can say directly that h is 2 and k is 1. Or you can compare this function with the general form minus square root x minus h plus k. Therefore h is 2 and k is 1. And now, because the sign of x is positive, therefore the domain starts from 2 to the positive infinity. And because the sign of square root is negative, therefore the range began from the negative infinity to the k, which is 1. Domain starts from 2 to the positive infinity, and the range from negative infinity to 1, as you can see in the graph of this function. The domain starts from 2 to the positive infinity, and the range is began from negative infinity to the 1. Example number 3. To find h, we cannot find h here directly, so to find h, every time you can take under the square root and equalize it to the 0. Then x minus 2x is equal to 0. Then taking 2x from left to right, then 2x equal to the 4. Dividing by 2, then x equal to 2. Therefore h is 2 and k is 1. And now, because the sign of x here is negative, therefore domain starts from the negative infinity to the h, which is 2. And because the sign of square root is negative, therefore the range began from the negative infinity to the 1, which is k. Domain starts from negative infinity to the 2 and range from negative infinity to the 1. Find the domain and the range of the function fx equal cube root x plus 2. Because we have odd root, therefore the range is and the domain is the all real numbers, as you can see here. The domain is from minus infinity to the positive infinity, and the range is began from minus infinity to the positive infinity. Example number 5. Find the domain of the range of the function fx equal 2 minus square root of x plus 1. Here, take x plus 1 equal to 0, therefore h is minus 1 and k is 2. And now, because the sign of x is positive, therefore the domain start from the edge, which is -1, to the positive infinity. And because the sign of square root is negative, therefore the range began from negative infinity to the k, which is 2. And now comparing these two functions, therefore h equal -1 and k is equal 2, and the start point is -1, 2. As you can see in the graph, that the domain start from h to the positive infinity because the sign of x is positive, and the range began from negative infinity to the 2, because the sign of square root is negative. Example number 6. Find the domain and the range of the function fx equal 2 plus square root of 1 minus x. When we equalize it, the x 1 minus x to the 0, then x is equal 1, then h is 1 and k is 2. And now domain start from, because we have the sign of x, is negative, therefore the domain starts from negative infinity to the h is equal 1, then it is 1. But the range is equal to, because the sign of square root is positive here, therefore is start from the start point to the positive infinity. Because k is 2, therefore is start from 2 to the positive infinity. Therefore domain is from minus infinity to 1, and the range is from 2 to the positive infinity. As you can see in this picture, that the domain starts from the minus infinity to the 1, as we said, and the range starts from the 2 to the positive infinity. If under square root was quadratic function, the first type, if the sign of the square root is positive, we have two types. The first one, if the leading coefficient a is positive when a is bigger than 0, then solve the equation ax squared plus bx plus c equal to 0 and find the value of x. If the value of x is x1 and x2, and x1 is less than x2, that means x1 is smaller than x2, therefore the domain is from minus infinity to the x1 and from x2 to the positive infinity, but the range is from k to the positive infinity because the sign of square root is positive. But if the leading coefficient is negative when a is less than 0, solve the equation ax squared plus bx plus c equal to 0 and find the value of x. Let the value of x be x1 and x2, and if we have x1 less than x2, therefore the domain is from x1 to the x2, which means is the closed interval from the small to the bigger number. But the range of this kind of function is from k to the k plus absolute value of x1 plus absolute value of x2 over 2. That means we take absolute value of 2 value of x and add it to each other, then divided by 2 and added to the value of k. Then it began from k to the k plus this value. And if the sign of square root is negative, then fx equal minus square root of ax squared plus bx plus c plus k. If the leading coefficient is positive, solve this equation and then find the value of x1 and x2. And if x1 is less than x2, then the domain is from minus infinity to x1 and from x2 to the positive infinity. But the range is from minus infinity to the k. But if the leading coefficient is negative, when a is smaller than 0, solve the equation under square root and find the solution. If the value of x is x1 and x2, and x1 is less than x2, therefore the domain is begun from the small to the bigger number, close interval. But the range starts from k minus absolute value of a plus absolute value of 2 x2 over 2 to the k. Example number 7. Find the domain and the range of the function fx equals square root of x squared minus 4. First of all, let's take under square root and equalize it to the 0. X squared minus 4 is equal to 0. Take minus 4 from left to the right, become x squared is equal to 4. Take the square root of both sides, therefore x is equal plus or minus 2. The smallest number is minus 2 and the bigger number is plus 2. Therefore, because we have the leading coefficient is positive, therefore the domain is start from minus infinity to the minus 2 union 2 to the positive infinity. But because we have k is 0, therefore the range is begun from 0 to the positive infinity because the sign of square root is positive, as you can see in this graph. The two value minus 2 and 2, the domain starts from minus infinity to the minus 2, then from 2 to the positive infinity. But the range is begun from 0 to the positive infinity. Find the domain and the range of the function fx equals square root of x squared minus 3x minus 4 minus 1. And now take under the square root, which is x squared minus 3x minus 2 equal to 0. Solve this equation and find the value of x. X minus 4x plus 1, then x is 4 or x equal minus 1. The smallest number is minus 1 and the bigger is 4. Leading coefficient is positive, therefore domain start from the minus infinity to the minus 1 and from 4 to the positive infinity. But the range, because the sign of square root is positive, therefore, and k is minus 1, therefore the range began from minus 1 to the positive infinity, as you can see in this graph. The domain began from minus infinity to minus 1 and from 4 to the positive infinity. But the range starts from minus 1 to the positive infinity. Example number 9. Find the domain and the range of the function fx equal minus square root of x squared minus 3x plus 2 plus 1. Take under square root and equal it to 0. X squared minus 3x plus 2 is equal to 0. then x minus 2, x minus 1 is equal to 0, then x equal to or x equal to 1. Leading coefficient here is positive, therefore the domain starts from the minus infinity to 1 and from 2 to the positive infinity. And because we have the sign of square root is negative, therefore range began from negative infinity to the 1, because k is 1, as you can see in this graph. Here domain starts from negative infinity to 1, from 2 to the positive infinity, but the range is begun from minus infinity to 1. Example number 10. Find the domain and the range of the function fx equal 1 plus square root of 3 minus 2x minus x square. First of all, write the function in this way. Fx is equal square root of minus x square minus 2x plus 3 plus 1. And now take under square root to the 0 and multiply it by minus 1. Then x squared plus 2x minus 3 is equal to 0. X plus 3, x minus 1 is equal to 0. Then x is minus 3 or x is equal 1. Because the coefficient, leading coefficient is negative, therefore the domain is the closed interval from minus 3 to 1. As you can see, from minus 3 to 1. But the range, to find the range, we have k is 1 and find the k plus absolute value of x1 plus absolute value of x2 over 2. x1 is minus 3 and x2 is 1, therefore absolute value of 3 is 3 and absolute value of 1 is 1. 3 plus 1 is 4. 4 divided by 2 is 2. Plus 1 is 3. Therefore, k plus absolute value x1 plus absolute value x2 over 2 is equal 3. Therefore, the range is begun from k, which is 1, to the 3. From 1 to the 3 is the closed interval. Example number 11. Find the domain and the range of the function fx equal minus square root 9 minus square root. And now, writing this function like this and take under the square root equal to 0, then solve this equation. You can find that the x is plus or minus 3. Because the leading coefficient is negative, therefore the domain is the closed interval from minus 3 to the 3. And because we have the minus square root, therefore find k is 0 and find k minus absolute value x1 plus x2 over 2. Therefore, x1 is minus 3 and x2 is 3. Therefore, minus 3 is become 3. And here is 3. 3 plus 3 is 6. 6 divided by 2 is 3. Then it is minus 3. Therefore, range is begun from smaller number to the 0, to the k. Minus 3 to 0, as you can see here. The domain from minus 3 to 3 and the range is from minus 3 to 0. Find the domain and the range of the function fx equals square root 4x minus x square. Take under square root equal to 0, then x becomes 0 or x become 4. Because we have the leading coefficient or the sign of x square is negative, Therefore, domain is the close interval from the small number to the big number, which means from 0 to the 4. Therefore, domain is from 0 to the 4. But to find the range, k is 0. And because we have here positive in sign of square root, therefore k is 0, and k plus absolute value of x1 plus absolute value of x2 over 2 is equal. K is 0, x1 is 0, x2 is 4, over 2 is equal to. Therefore, the range is begun from the smaller number to the bigger number. That means from 0 to the 2. Then range is from 0 to the 2. As you can see in this interval, the domain is from 0 to the 4, and the range is from 0 to the 2. Here we came to the end of the lesson. Please do not forget to write your comment and like the page and subscribe the page and build the ring. And thank you for listening and watching.